Thanks for joining me again. I'm A.M. Grabelny, one of the hosts of Are You Afraid of the Code? And we have been working towards building our digital spirit board, or as we've been calling it, a no-no board, since we learned that Ouija means we and ja, yes and yes, in French and German, respectively. Now, in order to bring Richard up to speed, I had been walking through an example of building a resurrectionist simulation. So the resurrectionists, as we had learned, were a group in the early 1800s, the late 1700s, that were there to assist anatomists or surgeons as medicine progressed. There was a drive to learn more about how the human body works. And in order to do that, they needed human bodies. And so the resurrectionists were a group of people that went and, as they put it at the time, body snatched. They went and dug up graveyards. Famous person involved in all of this, you might be surprised, was Benjamin Franklin. There was actually some skeletal remains discovered in the basement of his home in England, one of the places that he rented and stayed in while working in England. So doctors at the time didn't have access to bodies in a legal and safe way. People weren't donating their bodies to science at this time. All right, so we've been using this example to learn Go, and we learned quite a bit in our past few videos. This time we're focused in on one of the more complex parts of Golang, channels. All right, so channels go hand in hand when working with Goroutines, which we learned a bit about. And these Goroutines are how you deal with concurrency in Go. Now, Go isn't as focused in on parallelism as it is concurrency. These two topics can be a little confusing on what the difference is between parallelism and concurrency. Concurrency is doing things at the same time and how you handle doing more than one thing at the same time. Parallelism is spreading across different threads, different processors to do things at the same time also, but individually, right? So with concurrency, you may be sharing the same processor and you'll be swapping back and forth between things. And with parallelism, they have their own dedicated thread or processor. Go operates in both of those areas. It operates concurrently. It operates in parallel if you have multiple processors on your machine, if you have a CPU that's capable of multiprocessing. But Go doesn't rely on that directly. Go has its own concurrency mechanism called Goroutines with a very elaborate scheduler that runs alongside your program and schedules things to run. So I thought I would take us through an example with Goroutines to see what that means. So let's just get started here. We're going to make a package main. We learned what all this stuff means in the last couple of videos. So if you don't know what this means, you can go watch some of the older videos and see what this is. But remember, main is just how our program runs. It's what tells Go how to run our program when we do things like Go run, or when we build something and get a binary from that. So just to show you again, we'll just do our version of Hello World and say hello cemetery. And so I'm going to say go run command playground main. Now you might notice that this is a little different than the folder structure we had last time. You might have noticed that I added in this command folder. So if you've got multiple ways to run your program, you really can only have one main.go file in the root directory of your project. So in order to have multiple main.go files, we can actually split them out under something like this command file. Now, CMD calling it command, that's just a convention. It doesn't have to be called that. So let's run this. Boom, hello cemetery. Nothing new here, nothing that special. But let's talk about, so we're building this simulation, right? We were talking about resurrectionists. We've got a cemetery. We've got plots. Let's talk about, maybe we need to simulate what it's like to break into the cemetery, right? How the resurrectionists might have broken into the cemetery. So we're going to write go funct. And if you remember, that funct keyword is how you declare a function. We're declaring an anonymous function. That means a function that isn't named, that's just declared inline. So we don't reference this function anywhere but where it's declared. So it's different than having something like, a function declared right here at the bottom where I just say hi. And then I actually utilize the function by name, right? This is an anonymous function. I put the go keyword in front of it to signify that it is a go routine, right? So it's going to run on its own scheduled go routine thread. But these are not threads that are mapped directly to the threads on your CPU, just to make that clear. These are Golang constructs. These are go routines. So we're going to have a lookout. So I'm going to print a line here. I'm going to say starting lookout. So we want somebody to watch, right? Keep a lookout while our resurrectionist opens the cemetery gates, right? So I'm going to have another go routine here that says format.print line opening cemetery gates. So we're going to learn something very quickly here about go routines. We're going to learn neither of these are going to actually get to execute because the program's going to end too quickly. So we're not waiting for those go routines to finish. There's a couple ways to do that. We'll first look at what's called a wait group. So I'm going to do sync.wait group. There we go. And I'm going to say wait group dot done. Having defer with that wait group done, make sure that we're calling that function wait group dot done at the end of the execution of our anonymous function here. I'm also going to need to go ahead and add. So a wait group is a way of organizing together code and saying, okay, this code is going to run concurrently behind the scenes, but I want you to wait for it to finish, right? So we've got our wait group. We're adding something to be watched on the wait group, and then we're calling it to be done. So I also have to add my wait group dot wait here at the end, and my program's going to wait until the bottom here, and then it should print out, just to show you, goodbye cemetery. And that'll show you the order of how these things are happening now, since the wait group is waiting for one of our functions. We probably won't see opening the cemetery gates. So let's take a look. Well, we actually got lucky and we did see opening the cemetery gates because the wait group waited for one. But that's not true all the time. I'll even show you. If I add a time.sleep. All right, so now it's gonna, no longer do we see opening the cemetery gates. But we want to see both of these statements printed. So now I'm gonna add a wait group. I'm gonna do the same thing, defer, wait group dot done. And here we go. It's waiting the 5 seconds now. All right, there we go. These two things happen, as you can see, the ordering starting lookout happened first because you may be thinking, well, because it's listed that way. But no, we can change the order of this, and I can show you. Starting lookout still happens first. It's because it's what finishes processing first. Or we have two items in the wait group now. So we're waiting for both of these items to be done. The opening the cemetery gates, even though it appears above this function, right? Even though it appears first, doesn't finish first. So its output is not first. Can get confusing. Let's say we wanted these things to be synchronized up. So let's do that. We're going to do this with channels. Here's what we're going to do. We're going to make some channels. All right, so we'll have, let's say, the gate channel. And to make a channel, use the make command, and then you give whatever type you want as a value. We'll just say bool, because we're not going to be doing anything really with this value. And so a channel is an object that lets you communicate from different places in your program. And it's bidirectional unless you declare specifically. So let's say, for example, I'm going to send the gate channel in here. We're going to call it GC here, and it's a channel that I'm only allowed to write to. So send information in, and it's a bool. So if you want to do a receiver, which means get information from this channel, you can signify it that way. But the channel that I declared on line 12 here, it's a channel that is bidirectional. I can send information, I can receive information on it. So we're going to send information here. We're just going to send, we're going to say true. And this is how you send information over a channel. You use this operator here. And now we can also wait to receive information. So here's what I'll do. I'm going to get rid of adding one of these wait group here. And even before we define out the lookout, let's wait for this value, right? So is gate open? I'm just declaring that. And then I'm going to listen. So that means listen from the gate channel. And I'm going to say if the gate is open, the gate is open. All right. So all of this, since I have now made it wait. So this is a what they call a blocking call. That means I'm going to wait until there is, and I'm also going to close the channel. You should only close the channel from the sender side. You should never close a channel from the receiver side. If you send on a closed channel, so after you close it, if you send again, it will panic. It will crash your program. So this should allow me to wait for the gate information to be sent across this channel, and then I will start the lookout. All right, let's see if it works. So you can see it's waiting the 5 seconds, and it started the lookout after the gate was open. But really, we want to start the lookout first, right? We want to start the lookout first. So we're going to rearrange this order, okay? And, you know, let's say, I don't know, maybe we should wait 3 seconds before our lookout gets a little scared and says, all right, it's time to go. Okay, so we're going to let them know it's time to go after 3 seconds, which you'll notice is a shorter amount of time than our 5 seconds here. Okay, so we're already communicating on one channel. We're not using a channel yet for our lookout, but maybe we'll learn that we need a channel there too. Here we go. Let's run. There, we started our lookout first. That's great. Oh, but it's time to go already. So, but we still opened the gates. We didn't listen to our lookout. The lookout's not really able to do anything. Let's make a lookout channel. So now we need to communicate. It doesn't really matter what we send over the lookout channel. So I'll show you. This is a way you can just not have a value, not a significant value. We just send an empty struct to the lookout channel to let the lookout channel know, look, something's up. You know, you need to take an action based off of this. And we're also going to close the lookout channel because I said once we're done sending, right, we can close from the sender's side, but not from the receiver's side. Okay, but you're going to notice we're waiting on the gate, right? Now we can, I guess, wait on the lookout channel. We can get rid of the wait group at this point. We're not using the wait group for anything. But we're going to see, even though the lookout says, hey, it's time to go, and sends a message, it's not really going to do anything. We're still going to end up waiting for the gate. All right, it's time to go. The gate's still open. All right, we need to make sure that when that lookout sends us that signal, it's time to go. We got to get out of there. So how do we do this? All right, well, there's a special statement. It's called the select statement. Kind of like a switch statement, if you've ever seen a switch statement, but it's specifically for waiting on multiple different channels. So we're going to put in a case. We're going to wait. We're going to say we're actually going to copy this code down here. If we find the case of the gate channel giving us a message, then we're all good, but we need to check. Did we actually get the gate open? Maybe we didn't get the gate open. So if the gate is open, do something. Great. Now, what about our other case? So if the lookout channel signals, that means, well, it's time to go, isn't it? So then we can do a break statement there. All right, let's see what happens. Look at that. We didn't get the gate open that time. All right, so let's switch these. Let's increase our lookout time and decrease our opening the gate time. Starting the lookout. All right, there we go. Now we got the gate open. As you can see, you can use the select statement to wait for either one. Another very common thing to do with the select statement that we are actually technically doing with the lookout is to do a time.after. And let's say we want to do 10 times time.second timed out waiting. All right. We also need to give it the send signal. It actually returns a receiver. You can tell, remember I said, if you see that little arrow on the other side of channel, that's a receiver. It's sending back a receiver channel from that function. That time.after function allows us to set a timeout just in case, we want to break from functionality after a set of time. Maybe things are taking too long. Again, like where I have these time.sleep functionality pieces, you can think of those as like a call to a HTTP service or connecting to a database on getting a value out of that database. Those things take time, and it's usually not 5 seconds. It's a question mark. You don't know how many seconds it will take. So setting these two things off independently, you can have them go, and then you get to take an action based off of which one finishes earliest. All right. I think that puts us in a pretty good spot with channels and Goroutines to start putting together our simulation with Resurrectionists.